Okay, so finally, this episode, we are definitely going to get a Battlescape map done. We have one change to make though, first of all. In the create events of the map editor object near the bottom, you want to be. We're going to move this stuff here. We're in the setup, saving, loading region, and this code here, we're going to move it into the controller object. The reason for that is because we want to access this data from two different rooms, and this object obj map editor isn't going to be created when we're doing a Battlescape. Let's go into the controller object and let's just minimize this. And here we've moved it here, so just make sure we have this. Let me just show you the whole create event. So here we have the setup enums. Should look like that. And then we have setup biome sprites, which is this. Then we have saving loading, which is all of this. Minimize that region. And all this stuff is changes for this episode as well. So make sure you got that down, and then we want to make a new room called RM Battlescape, and we want to make a new object called obj underscore Battlescape as well. Okay, so in our new object obj Battlescape, we have a create event, which is pretty big. This is the vast majority of the code. Let me just minimize some regions. I did try and optimize it. Originally, I had the code where I work out what pieces are going to fit where, and after I've done all of that, then I load all the data into one big list of grids, and then I changed it so that while I'm working out whether a map fits in a place or not, I'm then filling in the big map with that data, which I thought would be better, but I don't know, it doesn't seem to have saved much space, if any. We're still up to, like, you know, over 100 lines. So if one thing to note, if all of our maps were only 10 by 10, it would be really easy. We would just pick a random map every time, and that would be it, for at least for this stage anyway. But because we can have maps of different sizes and we have to try and fit them in, the code is longer, but that also gives us the option to have varied maps. So, you know, pros and cons. Anyway, we're going to get the tile width and tile height and the camera variables. This is for, you know, later on for the drawing. Battlescape is going to be our list of floor grids for which we're drawing the final map with. We're going to set the biome as farm outside. Now, if you kind of think ahead, you know, if there's going to be a battle, we want to set what biome it is, and then the map is going to generate based on that. Hopefully we will have it to the point where we can just generate, you know, maps based on different variables we give it. Anyway, let's just get on with the code. Biome list is going to be our list of strings for our maps for that biome. If you recall, we're going to use a temporary biome list. What this is for is we're going to be checking, we're going to have like an empty floor grid, basically a very bottom level floor grid, and we're going to be checking if these maps are going to fit in that grid, map by map. If a map doesn't fit, we're going to clear it from the temporary biome list, which is going to be copied from the biome list, and then we're going to just keep trying maps from the temporary biome list until we find one that fits. It's very important that you have at least one 10 by 10 map per biome. Otherwise, you could have a situation where you don't have a map that will fit. As long as you have at least one 10 by 10, that we will always have a map that will fit in our generation. And anyway, so once any map that doesn't fit gets deleted from this list. It gets smaller and smaller until it finds one that will fit. And then once we want to start on a new spot to find a new map, we just copy over biome list back into the temporary biome list and start the process again. And that's how we're going to generate maps that will fit. A temporary list of grids is going to convert the data stored from the list. So say for example we get a string from our temporary biome list. It's going to be a list of grids. We're going to store that data in temporary list of grids, and temporary floor grid is going to be for each of the floor grids stored inside here, and that's how we're going to convert the data from strings into usable stuff. Why are we using temporary list though? Why don't we just copy it over? Why don't we just copy the maps over directly to the Battlescape? The reason is because we're going to be copying data to these two data structures, but we don't know if they're going to fit yet. If they fit, then we copy them over to the Battlescape. That's why we're using temporary stuff. Battlescape width and Battlescape height. This is how many 10 by 10 pieces wide should the map be. So this is basically 50 by 50. And then the actual number of cells is W and H, which is width and height. So 50 by 50. We're going to create our first floor grid, and we're going to add it to our Battlescape. The reason we are setting every cell to -1 in the floor grid is that's how we're going to tell whether it holds any data or not. We can't use 0 because 0 it could be a list. 0 is the starting number for lists, so we're going to set it to -1, and all we're going to be doing is to know whether a tile is empty or not. It's going to equal -1 in the floor grid. That's it. So here we have, it's pretty big. This is basically all the rest of the code. We have a double for loop for var map yy equals 0, map yy is less than Battlescape _h, map yy++, and the same for the xx. So we're going through all of these cells basically one by one. Well, actually, we don't do one by one. You see, we're going from 0 to 5 on each axis, but each axis has 10 cells, but we only really need to be checking the first of each of those 10 cells, because the smallest increment is going to be a 10 by 10. So as long as the first cell of that 10 by 10 is a -1, that means the rest of those 10 cells up and down is also -1. So that's how we know whether that 10 by 10 area is empty or not. So anyway, we're gonna grab the floor grids from our large Battlescape list, and I know we've already set it here and we've added it here, but we could be adding new ones, and we're going to be overwriting floor grid with those new floor grids, so it's just safer to reset it here as well. So here we're doing that check that I mentioned. If the floor grid map xx times base tiles per piece, so map xx is going to be 0 to 5, same for map yy. So we're going to be checking 0, 10, 20, 30, and 50 to see if those pieces are empty, although we're actually not going to get up to 50, so it's just going to be 0, 10, 20, 30, 40. As long as that entry is -1, then it means we need to generate a map for this area. So like I said, we copy over all the maps from biome list to the temporary biome list. We're going to shuffle our temporary biome list for randomness. So now the order is changed, and we're going to have a variable called fits, and all we're going to do is once we have confirmed that the map we've chosen fits, then we are going to update our floor grid and Battlescape, which we'll see. Well, that's this bit here. This region that we're going to open now is we're going to pick a random map and check to see if they fit, which is going to be fits equals true. So let's open this region now. So this is the code. Yeah, so map string is going to be the first entry of temporary biome list, which has been shuffled, so it should be random. We want to know how many horizontal and vertical pieces there are in that map. For example, a 10 by 10 is a horizontal and vertical piece of 1. A 20 by 20 is 2 for each, etc., etc. So that's all this code is doing, really. We're just converting that map string into a list of grids. We're going to get the first grid string, which is going to be the first entry of our list of grids. Convert that grid string into a usable data. So now we have a floor grid inside this. It's still got strings in every cell, but we just need to know the size of it for now. So that's all this is about. So right now we have a temporary list of floor grid strings. The bottom floor grid 0 has been converted into a grid. Cells in that floor grid are still strings though. They haven't been converted into lists yet. You remember, that's what that data is for. So, does the map fit? Well, we're going to set it to true, and if it doesn't fit, then we're going to set it to false, basically. So, we also want to know at what point in our Battlescape floor grids do we want to check. So we're going to be doing a very similar for loop as this here. So basically now 0 to 5, but it's only going to be from the point where we're up to in the Battlescape, plus the size of the map that we're checking. So say for example we are up to cell number 10 on the x-axis, and the map we're checking is 20 tiles wide. We're going to be checking from 10 to 30 basically. But again, we don't need to check every single cell, because every 10th cell, if it's not -1, that means there's a whole map in there. So anyway, we have to convert these coordinates into coordinates for our map, because our actual floor grid goes from 0 to 49. This is only ever going to go from 0 to 5 or 0 to 4. So anyway, XX and YY could be anywhere from 0 to 49. Well, that's not true really, actually. It's going to be 0, 10, 30 or 40 for these variables. Grab the floor grid from our Battlescape. If XX is greater than or equal to the width of our floor grid, so it's basically if XX is 50 or greater, or YY is 50 or greater, or the entry in the floor grid is not equal to -1, i.e. there's something there. If any of those three conditions are true, then the map doesn't fit, unfortunately. So we're going to set fits to false and break. What that's going to do is stop these for loops running, and we go back to the top, and then we should get the next map string. So this stuff runs, basically all this stuff runs until these conditions aren't true. And so if this runs and this is still true, then let's close the region, close this region. Then this region here is going to run. So we have a map that fits. We now have to copy over that data. So we have to calculate at what position we want to copy into our Battlescape grid. So we're going to get the start X and the end X and the start Y and the end Y. And it's just a rectangle in the grid that we're going to copy over to. There could also be more than one level for this map, so we have to use another for loop, which goes from I up until the size of our temporary list of grids. Get each floor grid string for each level. We may need a new floor grid for our Battlescape, because if I, i.e. the level, is greater than or equal to the size of our Battlescape, which only starts off at 1, then we're just going to make a new floor grid and add it to our Battlescape. Otherwise, if I is not greater than or equal to this, then just grab the next floor grid in the level for Battlescape. We're going to convert the floor grid string into our temporary floor grid. So now again we have a grid of strings in each cell, which we're going to need to convert into lists. We need some more coordinates to check temporary floor grid. We're going to go from 0 up until the width of it, and from 0 up until the height of it. That's what YY count and XX count is going to do. So this double for loop is for our Battlescape grid. We're going to grab the list string from our temporary floor grid, starting at 0, 0, going up to the width and height of the grid. We're going to make a list, because our Battlescape floor grids don't have any lists right now. Make a list, convert the list string from the cell of the temporary floor grid into a list, and save that list into our floor grid for the Battlescape, increasing X count for every one of these loops, and increasing Y count for every one of these loops. And we also need to be updating the map XX after all this stuff was done. After we've copied over all of the data, we just want to increase map XX. Say for example we've just added a map that's 30 tiles across. Normally map XX would just be increasing by 1, but we've already filled in that data, so we just want to get to the next point in our Battlescape floor grid to where to just after the map we've added. So that's why we are increasing map XX by H pieces -1. Why -1? Well, say for example we're adding a 10 by 10, H pieces would equal 1. We're already going to be increasing map XX anyway, so we don't actually want to increase this if H pieces is equal to 1. So this is only useful for maps that have 20 or more tiles, basically. More than 10 anyway. And I know that's a lot to take in. You're probably not going to understand all of it, even maybe any of it, I don't know, but I couldn't make it any easier, and also includes the functionality that I wanted to. I want us to be able to have maps that we can have of any, configuration, 20 by 10, 30 by 50, stuff like that. I wanted to have maps like that, and this is the best way, even after several attempts, that I can think of to do it. But if you have any questions, please ask me in the comments below. I'm always happy to answer and explain things, and that will probably help other people out as well. So now we've done this in the create event. In this step, all we're going to do is have some camera code. I literally just copied and pasted this from the map editor. It's the same code, which means we should probably make it into a script, but I'm too lazy for that. So in the draw event, it's pretty much the code from In the draw event, it's pretty much the code from the draw event of the map editor. It's the same kind of thing. Go from levels equals 0 until the size of the list. Grab the floor grid. How many cells, V cells, is the floor grid? Do a double for loop based on these two variables. Calculate the draw X and draw Y for our isometric tiles. Data is going to be a list. We're grabbing from the cell of the floor grid. Well, actually, it's not always going to be a list. It could just be nothing. But if it is a list, then we're going to use a for loop to draw everything in that cell, like the floor, west wall, north wall decoration. That's what this is for. Let's draw a sprite. We don't need the cursor, at least now. So I've left it in for now, but we don't need it. We don't need this code for this test anyway. But when we're actually playing the game, we can use this. And that's it for the draw event. And that should be everything. So now, if we run the game, we should be able to have a randomly generated map. So run the game, and you should have something like this, a randomly generated map. If you always get the same map every time, it's because you need to put randomize into the create event of the Battlescape object or the controller. Either one will do, but you should have something like this. So here's like a 20 by 20 map. These are two 10 by 10s. I think this is one. Is it one big one? No, these are the same clearly. And these, yeah, I think these are 10 by 10s as well. So we have some maps of different sizes basically. So you should have something like this. I did do a test with the city maps, and I have some strange bug with some of the upper floors. So if you have like a visual glitch, then don't worry, it's probably that bug that I haven't fixed yet, but I'll make sure that is done for next time. Anyway, thank you for watching, guys. I will catch you next time. Bye for now.